Today we're going to be talking about pressure and force. You're going to learn about the definition of pressure, how to convert between requested pressure units, and how pressure, area, and force are all related. Some vocabulary. The SI unit of pressure is equivalent, the Pascal is the SI unit of pressure. It's equivalent to 1 Newton meter squared. Torr, the unit of pressure, is equivalent to 1 millimeter of mercury. We'll use Pascal, as you guys have seen a whole lot more than you'll use Torr, especially in physics. Certain units are more common in different fields, and in physics we use the Pascal quite a bit. Pressure. Pressure is defined as the force exerted divided by the area over which the force is, and that should be an X there as an exerted. So our equation is pressure equals force divided by area. A simple example of this would be we could have 10 pounds being pushed over an area of 10 inches squared. So our force, our pressure here would be 1 pound per square inch. And that's how that would be with pressure. Obviously what we find out here then is area is very important as force is. You can make the area bigger and make the pressure less. It's kind of why people are able to lay across a bed of nails. Because if you were to step on a nail, let's say you weigh 200 pounds, all 200 pounds is being pushed down on that one nail. But if I lay down on a bed of nails, now I have 200 pounds, a much larger area. So the amount of pressure is a lot less because my force, the 200 pounds, is over a very large area. So my pressure is not nearly as much. Okay, we got a boy. Willie Oils, weighing 180 pounds, is wearing normal shoes. When he walks, at times all of his weight is on his heel. If his heel is 2 inches by 2 inches, what is the pressure exerted on his heel? Well, again, pressure is force over area. His force is his weight, 180 pounds. The area is 4 square inches. So it's 180 divided by 4, which gives us 45 pounds per square inch of pressure. A girl, Susie Burgess, weighs only 110 pounds. Her heel, however, is 0.5 inches by 0.5 inches. So she's got a much smaller heel on her new set of stilettos she got for her prom date at Central Noble. Find the pressure on her heel. Again, pressure is force over area. The force is 110 pounds. The area is 0.25, and when you divide that, 110 divided by 0.25, you get an answer of 440 pounds per square inch of pressure. And that's why women complain about their feet hurting a lot more than what men do. And that's why stilettos are considered to be such a bad shoe for women, because of the amount of pressure that's being applied to their foot. Also, it's why it hurts if a woman were to step on you with a set of stilettos as opposed to a guy stepping on you with his pair of work boots. If she were to step on you with the heel, she's applying 440 pounds per square inch approximately, whereas a guy with a pair of work boots is only stepping on you with a pressure of 45 pounds per square inch. Pressure is constant. Remember, pressure is one area in one area of a contained space will be the same in the different area of a contained space. What this means is we could have a balloon. All right, here's our balloon. And the pressure inside this balloon is going to be constant. It doesn't matter what place we look at this balloon, the pressure is the same all the way throughout the balloon. It's not like there's more pressure over here and less pressure over here. The same way at the classroom. You ever walk into a classroom and it feels kind of stuffy, or you get into a car, a hot car, in the afternoon it feels really stuffy? Well, that's because there's a lot of pressure. It doesn't matter if you sit in the front seat or the back seat, the pressure is going to be the same. Well, if the pressure is constant, it means it's not going to change, then what that leads us to is an equation where the pressure equals the pressure. In one part of the container, the pressure is going to equal the pressure in a different part of the container, and it gives us this equation down here. This is an important equation. All right, the force in one area, one part of the container, divided by the area in that part of the container is going to be equal to the force in one part of the container divided by the area in a different part of the container. So let's use this. Let's talk about a hand pump. Essentially a hand pump, oh, didn't mean to move that back up there. Essentially a hand pump looks about like this. And you've got this piston that you'll push down on it. And you've got this big piston, and out the other side is where the air will come out, and you might pump up your tire or a football or basketball or whatever you're pumping up. Well, the pressure here is equal to the pressure here. So what we can say then is our equation. Force over area is equal to force over area. Boy's using a hand pump to pump up his bike. The part he is pushing on is a 2-inch diameter cylinder. He is able to push down with 50 pounds of force. So it's 50. And I got to find out the area of this 2-inch diameter cylinder. That's 3.14. Now on the other side is this hose, and it's only 0.25-inch diameter. So on the other side here then, the area of that little hose is basically 0.05. The question becomes then, how much force is being pushed out of the other side? How much force is that air coming out with? Well, we can cross multiply and solve. Okay, I cross multiplied. 50 times 0.05 gave me the 2.05. F times 3.14 gave me the 3.14 F. That's pi. Divided by 3.14, and I found out that there is a force right here. This air is coming out with a force of 0.81 pounds of force, or 0.8 pounds of force. How about this 10-ton jack? Well, again, we're still going to use our same equation that we've been talking about here. Force over area, force over area. You've got a little piston over here which that people push down on, and then over here you've got this bigger piston which goes up. All right, they push down here on the little piston, and you get a certain amount of force and area on the other side. What tells us then that we have this we have a 3-inch diameter. So this load part over here has an area of 7.07. The other end where the mechanic will pump the jack is a 0.125-inch piston. So its area is 0.012. So this little area over here is only 0.012. How much force does the mechanic have to push down with to lift a 1-ton? So right here's where the 1 ton would be, 2,000 pounds. Well, we can cross multiply again. And when we do that, we find out the mechanic only has to push down with 3.4 pounds of pressure over here on this little piston to be able to lift a 2,000 pound object. Well, hey, that's our notes for today. I think that's going to be very beneficial for you. I'll catch you on the flip side.